Strip away the freeways, the towers, the whole grid of Dallas, and stand on the bare rock underneath the city. You are standing on a seabed. 600 feet of it, made almost entirely of dead plankton. So how did an ocean end up on top of Dallas, and where did all that water go? The teeth are still in the creeks. To understand how an ocean came to sit on top of a modern American city, we must travel back to a world with no ice at either pole. But the journey does not begin in the Cretaceous. It begins on a road west of Dallas on an ordinary afternoon. The land here is flat in the way North Texas is flat. Fields, fence lines, a water tower, the horizon doing nothing at all. And then it stops being flat. A pale ridge lifts out of the ground and runs away north and south, bright enough that it catches the light differently from everything around it. Where a highway has been cut straight through, the ridge lies open in cross-section beside the traffic. Two bands of rock. White on the top, dark gray underneath, almost black where the shadow falls across it. That pale ridge has a name. It is the White Rock Escarpment, and it is the western edge of the Austin Chalk. The chalk is the white band. Underneath it lies the Eagle Ford, a bluish-black mudrock that takes its name from a spot inside Dallas County itself. Between them, these two layers are the ground the metroplex is built on. The chalk alone forms somewhere between a third and a half of the county's surface, and it runs about 600 feet thick. Reunion Tower, the lit ball on a stalk that appears in every photograph of the Dallas skyline, stands 561 feet high. The chalk underneath the city is thicker than the city's most famous tower is tall. Below that sits another 475 feet of Black Eagle Ford mudrock. Together, more than 1,000 feet of stone. And neither of those layers was ever land. Neither was soil, neither was river gravel or wind-blown sand. Both were laid down grain by grain under open water, on the floor of a sea, and then lifted and left where they fell. The ridge beside the highway is not a hill with a marine history. It is a seabed standing up. So how many times has this happened here? More than once. This is not even the only fossil seafloor in the state. 600 miles west, out where the desert runs up against the New Mexico line, the Guadalupe Mountains stand above the plain. They are not a mountain range that happens to contain fossils. They are a reef. The whole structure was built along the rim of an inland sea, by sponges, by bryozoans, by algae, in an age before corals had taken over that work. It went down around 260 million years ago, in the middle of the Permian, tens of millions of years before the first dinosaur walked anywhere on Earth. So the story is not that Texas became a sea. Texas is a place that keeps becoming a sea. The Permian drowning, the Cretaceous drowning. Different oceans, different animals, the same low and patient ground, going quietly under the water. But only one of those drownings left shark teeth lying loose in the creek beds of a modern American city. So, what put a sea full of giant sharks on top of Dallas? And when it left, where exactly did it go? The answer starts with a planet that had no ice on it anywhere. "95 million years ago, there is no ice on Earth to speak of. Not at the top of the world, not at the bottom. Stand at the latitude where an icebreaker works today, and you find a coastline instead. Water that runs cool rather than frozen. Trees standing where no tree could survive a modern polar winter. The white caps that anchor every map you have ever looked at simply are not there. And the planet is running a different set of rules because of it. Through the Cretaceous, Earth carried no permanent polar ice sheets at all. That single absence moves an extraordinary quantity of water. Every cubic kilometer of ice that is not locked up on land is a cubic kilometer of ice sitting in the ocean instead, and the global sea level in this world stood somewhere between 100 and 200 meters above where it stands today. 100 meters is a 30-story building. Add a 30-story building of extra water to every coastline on the planet, and then ask what is still dry. So which ground goes under first? The flattest and the lowest. The engine driving it was in the air. Through the middle of the Cretaceous, atmospheric carbon dioxide, held at roughly 1,000 to 1,700 parts per million, something like 4 to 10 times the level the world carried before the first factories. So the ocean came up, and North America in the middle was low. Water pushed north out of the Gulf of Mexico and kept going. It crossed what is now Texas, then Oklahoma, then Kansas, and somewhere in the northern interior it met salt water coming down from the Arctic. The two joined, and the continent was cut in half. Geologists call the result the Western Interior Seaway, and its dimensions are difficult to hold in the head. More than 3,200 kilometers long, running pole to Gulf. Up to 970 kilometers wide. At its greatest extent, the deepest parts reached something on the order of 760 meters. 3,200 kilometers is Boston to Los Angeles. That is not a bay, or a flooded valley, or a big lake. That is an ocean with a continent on either side of it, and North America spent a long stretch of its history as two separate landmasses with open water in between. And it did not come and go in a season. The seaway held for roughly 34 million years. Our own species has existed for about 300,000 years. This sea was in place for more than 100 times. That uninterrupted, generation after generation of animals living and dying and sinking into it from the early part of the late Cretaceous until close to the end of the age of dinosaurs. So that is the first suspect, and it is the obvious one. The ocean simply rose. It is true, and it is not enough. A rising ocean does one thing above all others. It floods low ground, and flooded low ground always leaves the same signature behind in every era on every continent: a beach, a shoreline. A line in the rock where the water stopped and the land began. If a sea really did walk inland across Texas, that line is somewhere in the ground. And it can be found. So, where is the shoreline? As it happens, two of them survive. One is lying in a riverbed out in the hill country. The other is underneath a suburb. The first one is 113 million years old. And you can walk on it. Glen Rose, Texas. The tide is out, or whatever passes for out on a coast this shallow. The mud is soft, gray, and holds an impression the way wet cement holds one. A 2-ton animal comes across it on 2 legs, 3 toes spread, and each step it takes presses down through the surface layer and stays. Behind it, wide round depressions the size of dinner plates fill slowly with water. Something much larger has already passed this way. Those prints are in the limestone bed of the Paluxy River today, 90 minutes southwest of Fort Worth, and for most of the year, the water hides them. Then, in 2022, a severe drought dried the river down to gravel and handed over around 60 more theropod tracks that nobody had ever seen. The maker of the 3-toed prints was Acrocanthosaurus. 15 feet tall at the hip as an adult and close to 7 tons, a predator taller than a basketball hoop, walking on wet coastal mud. So is that the shoreline this story is looking for? Not quite. It is a shoreline, but at that date the Great Seaway has not yet formed. But it establishes the habit. North Texas was coastal country long before it was ocean floor. The second shoreline is 17 million years younger, and it does not sit out in the hill country. It sits inside the metroplex. Underneath, a stretch of North Arlington, between the housing and the roadworks, lie rocks of the Woodbine Formation, laid down between 96 and 94 million years ago. They preserve a coastal delta plain. Slow brown water spreading out through channels, a peat bog. Standing vegetation going down into the mud and staying there as carbon. It is the most complete fossil ecosystem known from this whole region of the ancient continent, and it is called the Arlington Archosaur Site. Lungfish, turtles. Ornithopod and theropod dinosaurs. And moving through all of it, something that has since been given a name. Deltasuchus motherali. A broad-snouted crocodile-shaped hunter, growing up to about 20 feet, which is longer than a pickup truck. Its bite marks are on the bones of the animals it ate. Turtle shell, dinosaur bone. It was not fussy, and it was found by a volunteer named Austin Motherall, working a small tractor at the site, who was 15 years old at the time. So the second suspect gives up what it was asked for. There are two coastlines here, 17 million years apart, both of them within a short drive of downtown Dallas. Texas had a shore, and it was not in the same place twice. But look hard at what that second shoreline actually was. Brackish channels, a peat bog, turtles and lungfish, and a 20-foot crocodiliform lying in the shallows waiting for something to come down to drink. That is a swamp at the edge of the water. It is not an ocean. Nothing in that delta needs 600 feet of chalk to explain it, and nothing in it is remotely large enough to account for what would eventually be swimming over the top of this same ground. So what was living in the water that swallowed that coast? For that, the evidence is not in a state park or a research dig. It is lying loose in the gravel of a creek just off an ordinary road an hour north of Dallas, and anybody is allowed to walk down and pick it up. Post Oak Creek, Sherman, North Texas. The morning after heavy rain. The water has dropped and left the gravel bars scoured clean. Among the wet limestone pebbles, there are shapes that do not belong to a creek. Black triangles, glossy, with fine serrations still standing up along the edges. Flat oval plates the color of dark honey, ridged across the top like the sole of a boot. A child could fill a pocket in 20 minutes, and children regularly do. Every one of them fell out of an animal that died in the sea that used to be here, and the rain is simply doing what rain has always done, unpacking the Eagle Ford Group one storm at a time. That rock is roughly 90 million years old. At least 5 species of the shell-crushing shark P. plicotus come out of this one creek, and the teeth are common enough that the city of Sherman has been turning a stretch of the bank into a public fossil park. Those flat ridged plates are not damaged teeth. That is the working surface of a shark that gave up cutting entirely and paved its jaws instead. The giant of that genus is a sixth species, Typicodus mortoni, and the skeleton that fixed its size came out of Upper Cretaceous rock elsewhere in North America rather than out of this creek. That specimen indicated an animal of at least 10 meters, with a jaw close to a meter long. 10 meters is a city bus. The jaw alone is about as long as a person is tall, and every surface inside it is built for crushing. So what kind of animal carries a meter of grinding plates around an open ocean? For nearly 2 centuries that was read one way, a slow, heavy bottom-grubbing thing, mouth down in the shell beds, closer to a living millstone than a predator. Then, in 2024-6, near-complete skeletons were described from Vallecillo in Mexico, and the body attached to those famous teeth finally appeared. It was not a bottom grubber. It was a mackerel shark. Streamlined, large pectoral fins, a tail cut for fast cruising in open water, closer in build to a living porbeagle than to anything on the sea floor. The crushing dentition was for ammonites and sea turtles. And it ran them down, and it was not alone out there. Cretaceous crassidens, one of the largest predatory sharks of the entire late Cretaceous, comes out of the same rock at Sherman. Cretoxyrhina, the shark that later collectors nicknamed the Ginsu, ran between 4.5 and 7 meters. And a tooth of 63 millimeters has been recorded from Austin Group gravels in Texas. That is a single tooth, as long as an adult's index finger. And swimming among them, Xiphactinus, not a shark. A bony fish 5 meters long, more than 100 vertebrae down its spine, with an upturned bulldog jaw full of fangs and pectoral fins held out stiff like wings. A complete 5-meter skeleton has come out of the Ector Chalk in northeast Texas. Elsewhere, specimens have been found with whole smaller fish still sitting intact inside the ribcage, swallowed and never digested. So the third suspect delivers something the Delta could not. Open ocean hunters do not live in a lagoon. Fast pelagic sharks and a fanged fish that ambushed prey in open water require real sea, salt and deep and connected to the wider ocean over the top of North Texas. But a fauna is a snapshot. It tells you what the water was. It cannot tell you how long the water stayed. So how long does an ocean have to sit on a continent before it starts building rock? Long enough, in this case, that the rock it built is the reason that Pale Ridge out west of the city is pale at all. If you could stand on that seafloor and look up, the first thing you would notice is not the sharks. It is the snow. The whole water column above you is filled with small, white particles drifting downward, unhurried, continuous, in every direction you turn. Nothing disturbs it. It has been falling before you arrived, and it will still be falling long after. And where it lands, it makes a soft, pale carpet that your foot would sink into up to the ankle. That snow is the Austin chalk before it becomes rock. Almost the entire white band is made from a single kind of object. The calcium carbonate plates of coccolithophores, single-celled algae that live near the surface, build tiny armored discs around themselves out of dissolved carbonate and then die. The discs come apart and sink. Each individual plate measures somewhere between 1 and 5 microns across. A human hair is about 70 microns wide. You could lay 14 of those plates side by side across a single hair and still have room. And they settle at the speed you would expect from something that's small. Chalk ooze accumulates on a seafloor at roughly 1 to 6 centimeters per 1,000 years. Consider what that means. An entire human lifetime of that snow falling, every day without pause, would not be enough to bury a coin lying on the bottom. So how do particles that small ever build a cliff? By never stopping. Now go back to the number this began with. 600 feet of it under Dallas County. Take the fastest rate anybody measures. 6 centimeters per 1,000 years and 600 feet still needs on the order of 3 million years of continuous falling plankton. Slow the rate down and the requirement climbs. And the dating agrees with the arithmetic. That band of chalk was laid down between roughly 86 and 83 million years ago. 3 million years of snow. And because chalk compacts under its own weight as it hardens, the original ooze was thicker than what survives. There is one more thing the chalk gives up. It was deposited below storm wave base, in water estimated at least 300 feet deep. That is not a technical footnote. It means that when a hurricane crossed this sea, and hurricanes certainly did, the waves it threw up could not reach the bottom. The inks kept falling through the storm, undisturbed, because the storm was happening too far above to matter. So the fourth suspect answers the question it was called for. The rock is a clock, and the clock says millions of years. This was not a flood, or a wet century, or a shallow arm of the Gulf sloshing over the state and retreating. There was an ocean here, deep and open and quiet on the floor, for a span of time long enough to build 600 feet of stone out of dead algae. But stand back at the highway cut for a moment and look at the whole exposure again. Not just the white part. Because there is a problem underneath it. Below all that clean pale chalk, the Eagle Ford sits thick and dark and nearly black, and black is not what a healthy seafloor produces. A working ocean bottom is gray or brown, churned and burrowed and picked over by the things that live in it. So what turned the floor of this sea black? The answer is that for a long stretch of its life, nothing down there was alive to turn it over. "95 million years ago. The same patch of seafloor long before the first chalk falls on it. Nothing burrows here. Nothing crawls across the surface. Nothing pushes a trail through the top centimeter of mud. Nothing turns anything over. A carcass comes down out of the water above, touches the bottom, and settles into the ooze exactly as it landed. It is not torn open. It is not scattered. Days pass, weeks pass. It is still lying there, whole, because there is nothing on this floor with the metabolism to take it apart. That is what black mudrock records. Not a violent event. An absence. The Eagle Ford was laid down under bottom water that had almost no dissolved oxygen in it, and for stretches of that time the water was worse than merely starved. It was oceanic, meaning free hydrogen sulfide in the water column itself, the chemistry of a stagnant pond scaled up to the floor of an ocean. Organic carbon that reached that bottom did not get eaten and did not get oxidized. It got buried, which is exactly why the rock is dark. Now hold the two layers of that highway cut side by side, because they are not the same ocean twice. The white chalk above was deposited under oxygenated water, a floor with things living on it, snow falling through a healthy sea. The black rock below was deposited under water, where the deep floor was effectively dead. Same place. Same basin, stacked one directly on top of the other, with the boundary between them visible from a car window. So, was that a Texas problem or a planetary one? The black layer was not a local accident. Close to 95 million years ago, at the transition between the Cenomanian and the Turonian, the world's oceans went through the most extensive anoxic event of the entire late Cretaceous. It is called Oceanic Anoxic Event 2. Carbon burial spiked across the planet. The event ran for roughly 500,000 years. 500,000 years in which the deep floor of the ocean, over enormous areas of the Earth, had nothing living on it. So the story writes itself. The global crisis arrived, the Texas Sea went dark with it, and the black rock under Dallas is a local page of a worldwide event. Except that is not what the Texas rock says. The shelf here had already gone anoxic more than 1 million years before that global event arrived. 1 million years and more of black mud going down on this one bottom while the rest of the world's oceans were still functioning normally. Texas was not following the crisis. Texas was early. That is the fifth suspect, and it is the one that gets cleared. Anoxia is unquestionably guilty of the black layer. It is guilty of burying the carbon. But it did not kill this sea, and the proof is sitting directly on top of it. The black mudrock stops. The water clears. The floor comes back to life, and then spends millions of years quietly accumulating white chalk over the grave of the dark interval. The ocean over Texas survived its own suffocation and carried on for more than 20 million years afterwards, right up until the continent evicted it. So if suffocation did not end this sea, who inherited it? Something did, and what the rock under Dallas holds is not only the animals that ended up ruling this water. It holds an earlier moment when their whole group had not yet finished deciding whether to live in the sea at all. "92 million years ago, at the shallow edge of the Texas shelf. An animal about a meter long comes down over the wet ground toward the water. It is a lizard and it moves like one. It has 4 legs that work. It has feet with toes that push against the sediment and take its weight. It is roughly the size of a large dog, and there is nothing about it that looks like the ruler of anything. It reaches the shallows and goes in, and the body that carried it down the beach carries it just as well through the water. That animal has a name now, and the name is a joke that turned out to be accurate. Dallosaurus turneri. It was described from 2 incomplete skeletons out of Middle Turonian rock in north-central Texas, and what makes it valuable is precisely what it still had. Functional walking limbs, not paddles, not flippers with the finger bones fused into a blade. Legs and feet that could still operate on land, on an animal whose relatives were already committing to the sea. And the trail that led to it started with almost nothing. A single vertebra picked up at a construction site near Dallas by an amateur collector named Van Turner. It took years before anyone worked out what they were holding. The formal description came in 2005 from Michael Polson of Southern Methodist University and Gordon Bell, and the species name honors the man who found the first bone. So what is an animal with 4 working feet doing in the rock of an open sea? It is doing what its entire group was doing at that moment in Texas. Arriving. Here is the part that gets misfiled almost every time. Mosasaurs were not dinosaurs. They were not marine dinosaurs, or swimming dinosaurs, or dinosaurs that went back to the water. They were lizards, squamates. The same branch of the family that produced monitor lizards and snakes which walked into the ocean during the Cretaceous and stayed. And the rock under Dallas holds that transition in progress. Not the finished product, the middle of it. A lizard in Texas with its legs still under it, in water that would eventually belong entirely to its relatives. Now move forward 12 million years in the same seaway, over the same drowned state. The rock from that later interval records something with no use for a shoreline at all. No walking limbs, no ambiguity about where it lives. A body built end to end for open water, arriving out of the blue distance with the deliberateness of an animal that has never in its life needed to hurry away from anything. In May of 2026, that animal was given a name of its own, Tylosaurus rex. It was described in the Bulletin of the American Museum of Natural History by Amelia Zietlow, working with Ron Tikoski and with Michael Polson, the same researcher who had put a name to the little lizard with legs 2 decades earlier. The estimates put it between 25 and 43 feet long. At the upper end of that range, it is longer than a school bus and roughly twice the length of the largest great white sharks alive today. Its teeth were finely serrated, which most of its relatives cannot claim, and the muscle attachment sites on the skull are enlarged in a way that points to an exceptionally powerful bite. The skeleton also carries damage, and the damage is the interesting part. It shows evidence of violent fighting with its own kind, at a level not seen in other tylosaurs. In the words of the lead author, and this is a direct quote, "Everything is bigger in Texas, and that includes the mosasaurs, apparently." And where does a body like that turn up? On the edge of a modern American city, under a reservoir road. The skeleton that carries the name came out of the ground near Lake Ray Hubbard, immediately east of Dallas, in 9,979. It sat in a collection for decades before anyone established what it was. It now stands mounted in the Perot Museum of Nature and Science, in the middle of the city that its ocean used to cover. So the sixth suspect gives a verdict, and it needs saying carefully. The small lizard with legs is not the ancestor of the 40-foot hunter. Those two sit on different branches of the mosasaur family, and the branches had already separated. What the Texas rock preserves is not a single lineage caught growing. It is 2 snapshots of one enormous radiation, taken 12 million years apart in the same body of water. And that is the point. Only a sea that stayed warm, stayed productive, and stayed undisturbed for millions of years on end can record both of those moments in the same stack of rock. This ocean was not fragile. It built its own giants and it kept them. Which means that whatever finally ended, it did not come from inside the water. So what came from outside it? something slower than any extinction and much harder to see. The floor itself began to move. How did an ocean full of giant sharks come to sit on top of Dallas? And where did all that water go? The first half of that question now has most of an answer. A greenhouse world with no ice at the poles raised the ocean. The Gulf pushed north across a low continent and met the Arctic, and what arrived over Texas was real open sea, deep enough and stable enough to run for millions of years and build its own monsters. The second half is harder, and it does not happen in the water at all. It happens underneath it. Off the western edge of North America, an oceanic plate called the Farallon was sliding down beneath the continent. That in itself is ordinary. What was not ordinary was the angle. Instead of dropping steeply into the mantle, the slab went under at a shallow pitch and kept traveling inland, scraping along the underside of the continental crust for hundreds of miles before it descended. And a continent being pushed from below responds the way any sheet does. It buckles, it thickens. It rises. That is the Laramide orogeny, and it is the event that built the Rocky Mountains. But the mountains are only the visible part of it. The same uplift was lifting the entire floor of the interior basin, gently over an immense span of time, across an area far wider than the mountain front itself. So how do you get rid of an ocean that size? You do not. You lift the continent. The sea was not being drained. It was being handed a shallower and shallower container. And it was being squeezed from the other side at the same time. Global sea level, which had spent the Cretaceous standing 100 meters and more above the modern shoreline, began to come down from that high. Whatever the water was losing to the rising floor, it was no longer being topped up from the ocean either. Rising land, falling sea. Sediment pouring in from both flanks and filling what remained. The retreat began around 75 million years ago, and it was not a single dramatic event. It was staggered, uneven, spread across millions of years. In one place, the water withdraws and mudflats appear. In another, it holds on for another million years, then goes. The shoreline that had been so far east it drowned north. Texas walks back the way it came, in fits, over a span of time longer than most species last. And then, somewhere between 70 and 66 million years ago, the connection breaks. The continuous waterway that had cut the continent into two landmasses stops being one ocean. It becomes disconnected remnants. Shrinking arms of water. Swampy lowlands where a seaway had been. The two halves of North America, separated since the middle of the Cretaceous, quietly become one continent again, and the sea that had stood over Texas since long before the Rockies existed is simply no longer there. So the seventh suspect returns the verdict the question needed. The water over Dallas was never drained, and it never dried up. It was displaced. Pushed off the top of a continent that came up underneath it, at a rate no animal alive in that sea could have perceived in 1,000 generations. And that distinction matters more than it sounds, because of what it does to the evidence. When water evaporates, it concentrates and it wrecks. Salt, gypsum, ruined bone. When water is simply pushed off a shelf, nothing on the floor is disturbed at all. Every plate of plankton, every shed tooth, every carcass that settled into the black mud stays exactly where it fell, and the ground closes over it and holds still. So what did this one leave behind? Far more than fossils. The dead part of it turned out to be worth more than everything else combined. So put the whole chain together, because no single thing put an ocean on top of Dallas. Each link pulled the next one into place. It starts in the air. A greenhouse world with no permanent ice at either pole, which leaves the water that should be frozen onto land standing in the sea instead, and global sea level far above the modern shoreline. That raised ocean finds the lowest ground on the continent and takes it. The Gulf pushes north across the interior until it joins the Arctic water descending to meet it, and North America is cut in half. Open ocean follows the flooding inland, which is the only reason fast pelagic sharks and a 5-meter fanged fish end up hunting over North Texas at all. The water column stratifies. The bottom loses its oxygen, organic carbon stops being eaten and starts being buried, and the seafloor turns black under a functioning ocean above it. Then the bottom recovers. And for the next few million years, the water is deep enough that storm waves never touch it, while dead plankton rains down onto the top of that black grave and slowly turns into stone. And finally, the Farallon slab lifts the continent from underneath while global sea level falls from the other direction. And the sea is squeezed out from both sides at once, leaving its own floor behind as the bedrock of a city that would not exist for another 66 million years. That is the answer. Not one cause. A sequence where every step made the next one possible. So, why should any of that still matter to the people living on top of it? Because the sea did not only leave fossils behind. And the dead black layer, the one that looked like the failure in the story, turned out to be the most consequential thing the sea ever produced. All that buried, uneaten carbon cooked slowly under its own overburden for tens of millions of years and became oil. The Eagle Ford is the source rock for the Austin Chalk play and for the giant East Texas oil field, and eventually people learned to take it out of the shale directly. In 2008, the Eagle Ford produced 352 barrels a day. By March of 2015, it was producing more than 1.7 million barrels a day, and in 2024, it was still running around 1.2 million, one of the most productive oil regions in the country. A suffocated Cretaceous seafloor is paying for a substantial share of modern Texas. And was the Cretaceous the last time water took this place? It was not. Texas did not stop drowning when the sea left. At Waco, roughly 65,000 years ago, a nursery herd of Columbian mammoths was caught by rising rivers and buried in flood mud. Adults as tall as a 2-story house and the young animals with them. 24 have been recovered from that one site. It is the only mammoth nursery herd on record anywhere in the United States. And the thing that killed them was water arriving faster than they could climb out of it. Which brings this back to where it started, beside a highway west of the city. The teeth are still coming out of the creek at Sherman after every hard rain, and children are still filling their pockets with them. The mosasaur that ruled that water stands, mounted in a museum in downtown Dallas, a short drive from the Pale Ridge where the old seafloor comes to the surface and shows itself in cross-section to anyone driving past at 70 miles an hour. None of it is hidden. It never was, and perhaps the harder question is not how an ocean came to sit on top of Dallas. It is how briefly the ground under any city ever holds still, and what the rock beneath the one you are in right now is quietly waiting to become. Thank you for watching Mystery Origins. If you want more of the deep past hiding under ordinary ground, there is plenty of it here.